Hey everyone, and welcome. So I want to let you in on a little secret about the world of coding. It turns out pretty much every programming language out there is built on the exact same set of core ideas. And once you get those, you can learn any language. You ready? Let's dive in. So, if you're just starting out in software, does looking at the huge list of languages kind of make your head spin? I mean, you've got Python, Java, C++, JavaScript. The list goes on and on. It's like, where do you even begin, right? It can feel like you have to climb a totally different mountain for each one. But what if I told you they're all just different peaks in the same mountain range? Okay, just to give you an idea of this crazy landscape, take a look at something called the TOBE index. It's basically a monthly ranking of how popular different languages are. It looks at stuff like search engine data, how many engineers are out there, that kind of thing. Now, the point here isn't to find the best language. That's not what it does. It's really just to show you how many choices there are, which makes it super important to find what they all have in common. All right, so here's how we're going to break this all down and cut through that complexity. First, we'll tackle why there are so many languages in the first place. Then we'll get to their universal purpose. After that, we're going to get into the real nuts and bolts: structure, variables, data, and how to control a program's flow. And we'll wrap it all up by looking at the major styles of programming. Okay, first up, a world of languages. Let's tackle that big question. Why are there so many different ways to code? Well, the answer is actually pretty simple. It's all about using the right tool for the job. You wouldn't use a hammer to saw a piece of wood, right? It's the same idea here. Back in the day, you had super specialized languages like COBOL for business stuff and Fortran for heavy-duty scientific calculations. Today, you've got languages like C and C++ that are awesome for the Internet of Things because they're just so fast and efficient. And then you have something like Python, a general-purpose language that can do a little bit of everything. It really just comes down to different problems needing different solutions. All right, on to section 2, the universal purpose. So even with all those different tools, what's the one thing every programming language is trying to do? At the end of the day, their one big job is to give instructions to the computer's hardware. Simple, right? Well, there's a catch. The hardware, the actual chips, only understands one thing: machine code. And that's a low-level language of just ones and zeros. I mean, trying to write that directly would be a nightmare. So what we do is use high-level languages like Python or Java, stuff that's actually easy for us humans to read and write. Then, a special program, either a compiler or an interpreter, does the heavy lifting and translates our nice, clean code into the messy ones and zeros the computer can actually understand. Okay, now we get to the really good stuff. Section 3 is all about structure and variables. Think of these as the basic grammar and the storage containers for any language. So pretty much every language needs a way to group related lines of code together, and a super common way to do this is with what we call a block structure. In languages from the C family, you'll see curly braces used for this and often a semicolon at the end of each line. But here's the cool part. Even a language like Python, which famously uses indentation instead of braces, is using the exact same idea. The underlying concept of a code block is there, it just looks a little different. So where does all the data your program is working with actually go? It goes into variables. You can just think of a variable as a labeled box in the computer's memory or RAM. That's it. So whether you're keeping track of a player's score, a user's name, or the price of something in a shopping cart, you're sticking that information in a variable. It is without a doubt the most fundamental storage unit in all of programming. All right, let's keep building on that. Section 4, data and data structures. So we've got our containers, our variables. Now let's talk about the different kinds of stuff we can put inside them and all the clever ways we can get it organized. You see, you can't just toss data into a variable and hope for the best. You have to tell the computer what kind of data it is. And these are the absolute basics you'll find everywhere. Int for integers, whole numbers. Float for decimal numbers. Char for a single character. A string for a bunch of characters, like a word. And a boolean, which is just a simple true or false. And defining that type is so important because it tells the computer exactly how much memory it needs to set aside for that piece of data. Now, once you start dealing with more than just a few pieces of data, you've got to get organized, and that's where data structures come into play. I love this analogy. Think of your individual data types as bricks. A data structure is the building you make with those bricks. It could be a simple house or a massive skyscraper. The whole point is to arrange your data in a way that lets you work with it super efficiently. Let's look at two of the most fundamental examples you'll ever see. First, an array. This is like a row of mailboxes on a street. Everything is the same type, and they're all stored side by side in memory, one right after the other. A A linked list, though, is totally different. It's more like a scavenger hunt. The items can be scattered all over the place in memory, but each one holds a little note, the memory address, that tells you exactly where to find the next one. You see? Two different ways to build, but the core concepts are found everywhere.
Okay, so we have data and we have it organized, but a program that just runs straight from top to bottom isn't very smart, is it? We need it to make decisions and repeat actions. This is all about controlling the program's flow.
The most basic, fundamental way to make a decision in your code is the good old if-else statement. You'll find this in basically every language. It's super simple. Your program checks a condition. Is it true? Okay, then do this block of code. Is it false? No problem. Then do this other block of code. Or just skip it and move on. That's it. It's the basis of all decision making.
And what if you need to do something over and over and over again? Well, that's what loops are for. And let me tell you, computers are amazing at doing repetitive tasks without getting bored. The name might be slightly different. You'll see for loops, while loops, do-while loops, but the core idea is always the same. Execute this chunk of code again and again until some condition is met that tells you it's time to stop. And to actually do stuff with all our data, we need operators. These are just the symbols that perform actions. You've got your arithmetic operators for math, relational ones for comparing things, the assignment operator for putting a value into a variable, and logical operators for combining conditions. The actual symbols might look a little different language to language, but these fundamental jobs exist everywhere. All right, time to zoom out a bit for our last section, programming's major styles. Beyond all the little building blocks, there are these bigger picture philosophies or approaches to how you build your software. Let's look at the two big ones. So the two main schools of thought here are functional programming and object-oriented programming, or OOP. Functional programming basically treats everything like a series of math functions. Data flows through these functions, and the idea is to avoid changing data directly. Now, OOP is different. It's all about creating objects that bundle together both the data and the functions that work on that data. It's a really great way to model real-world things. For example, you could have a user object that contains the user's name and the function for changing that name all wrapped up together. And this, right here, this is the whole ballgame. This is the most important thing to take away from our entire chat today. It's the difference between syntax and semantics. Think of syntax as the grammar. Do you use a semicolon at the end of a line, or do you use indentation? That stuff varies between languages. But the semantics, that's the meaning of the concept, the idea of grouping code into a block, or the idea of a loop. That stuff is shared across almost every language. So here's the real magic. Once you truly master the concepts, the semantics, learning a new language just becomes a simple matter of looking up the new grammar. That's it. That's the secret to becoming a truly flexible, effective programmer. Focus on mastering the ideas, not just memorizing the rules for one specific language. Now we've covered the big ones today. Variables, loops, data structures, all that good stuff. But of course, there's more out there. So I want to turn it over to you. What other features have you seen that seem to pop up in almost every programming language you've looked at? Let me know what you think down in the comments below. Hey, if you enjoyed this little explainer and got something out of it, do me a favor and hit that subscribe button for our channel, Computer Science Made Easy. We've got a lot more stuff like this coming. And hey, if you know someone else who's trying to wrap their head around coding, feel free to share this on your social media. Thanks so much for hanging out, and we'll see you in the next one.